Welcome back to DxePrep Calculus, and in this is the second video of the tabular method, and I'll attach the link to the first video in the description. So let's say we wanted to find the integral of ln of x squared. Now that seems like it'd be a lot of work because you'd have to plug and chug the integration by parts formula. So let's first do that, and then we'll see how we can do that by using the tabular method. So let's first do integration by parts. So in this, I'm going to keep u as the ln of x, and I'm going to keep dv as x squared. So basically what that means is integral of u, which is ln of x squared dx, is equal to uv. So u is ln of x, and v is the integral of dv, which is x cubed over 3 minus the integral of v, which is x cubed over 3, or the integral of dv, which is v, times du, which is 1 over x. Because the derivative of ln of x is simply 1 over x. And that gives us the ln of x cubed over 3 minus, we can simplify this to be the same thing as x squared over 3. And that just gives us the integral of x squared over 3 is x to the power of 3 over 9. X cubed over 9. So that's just their final answer. So now let's try applying the tabular method to actually solve this. So I'm just going to note down the answer over here. So now we're ready to use the tabular method. So first we're going to draw the rows, and on one side we have the derivative, which I'll just abbreviate as der, and then we have the integral on the other side, which I'll just abbreviate as int. So since we're going to keep ln in the derivatives, we're going to keep ln in the derivative side, and on the integral side we're going to keep x squared. And remember to put pluses and minus down here. Okay, so the derivative of ln of x is 1 over x. And the derivative of 1 over x is negative 1 over x squared. And as you know, the derivative of ln of x will never reach 0, as was the case in the last video where we talked about when we would stop when one of the derivatives reached 0. In this case, it doesn't happen. So let's see what happens when you take the integral of x squared over 2. That's just x cubed over 3. And we notice something here. 1 over x and x cubed over 3 are like terms, meaning that they can be factored out or cancelled. So another way to stop the tabular method is when we reach the like terms. And this isn't the same thing as ln of x cubed over 3 times 1 over x times x cubed over 3. No, in fact, this is an integral over here. Each row represents an integral. So the way we're going to interpret this is positive ln of x times x cubed over 3 minus the whole row is an integral. So an integral of 1 over x times x cubed over 3. And this looks awfully familiar to this looks the exact same as what we had last time actually. So we can just cancel this out, and this just leaves us with x squared over 3. So I'm going to write that here. And the integral of x squared over 3 is simply just x cubed over 9. So this just leaves us with ln of x cubed over 3 minus x cubed over 9 plus c. And I'll add the plus c over here. So we see that it's the same answer on both of these. So that must mean that it works. So just a reminder that the other method when we stop is when the derivative and the integral are like terms, meaning that they can be cancelled. And in the next video, we'll look at another case of using the tabular method.